I couldn't possibly start without thanking Brandon for the invitation and for having put together the conference. On a topic which is extremely dear to my heart. And I think I could start with a remark about culture by suggesting that with this Twitter question forum, we might have a hint of entering in a new academic culture. Another use of the word culture as the use you've made when you've evoked snow. I hope you will bear with my accent, which has layers of accents coming from everywhere in the world. So it's no longer even French accents, it has all kinds of flavors. I hope it can still be comprehensive. We shall see. Well, today I have chosen to approach the topic of mathematical cultures, and the S is extremely important for me, from the viewpoint of text, and from the viewpoint of these peculiar textual phenomena that signal adherence to a given mathematical culture. And I would like to make a footnote right here to emphasize the fact that every time I shall be using the word culture, I will mean mathematical culture. This is what I focus on, and there are other wider uses of the word culture that I'm not touching here. So there are, I suggest, some textual reflections of the fact that the practitioner is operating within a given mathematical culture. There are some textual phenomena that echo the fact that this practitioner is doing mathematics in a particular way. I'm not going to develop what I mean by doing mathematics in a particular way. One can take into account the things with which one works, one can take into account the values that are prized by the practitioners, one can take into account many things. We could think collectively of what are the components that are important to try to characterize a given way of doing mathematics. What I would like to focus on today is the cultural phenomena that relate to ways of structuring texts. And I'm going to deal with this question by reference to ancient mathematical sources, but I believe that this question of how practitioners structure their text is an issue of much wider relevance, much wider importance. Let me start with an example, and that's an example you probably all know, which is the example of Euclid's Elements or any other similar Greek text. I have not said all Greek texts, but a bunch of Greek geometrical texts. You all know that the positions in Euclid's Elements and coordinate geometrical Greek texts have a specific structure. A structure that was described in the 5th century by Properus. Among propositions you have either problems or theorem, and each of these things has a statement followed by an exposition, followed by a determination, followed by a construction, followed by a proof, followed by a conclusion. These are the parts that Proclus set forth to describe the structure of an Euclidean proposition. So writing a book in the context of mathematical cultures, in which the elements were recognized as an essential text, implied to compose an architecture of propositions having each a specific set of parts. I think that most modern historians recognize the structure of the text of such a proposition right away, and yet they tend to overlook it, as if it was a matter of mere form and did not affect, in fact, the content, which we believe is statements, demonstrations. However, when we overlook the fact that a proposition in Euclid's elements has parts, first of all, we may be overlooking signs that indicate a given culture, a given way of doing mathematics. But we may also create for ourselves problems in interpreting the text. In fact, and here in this comment I'm relying on a PhD thesis written by Felix John, who is about to defend his PhD thesis in Paris. In fact, it is essential to interpret Greek mathematical texts of antiquity to bear in mind, as practitioners in ancient Greece did, to bear in mind this structure of the proposition. It's essential to interpret their text and thereby interpret their practice. So, my claim, and this is what I offer for interdisciplinary discussion, my claim is that mathematical texts are structured in a specific way that is meaningful for practitioners, that signals the fact that these texts are composed within mathematical cultures in the context of which these practitioners operate, and that these parts in which mathematical texts are structured are essential to take into account to interpret the text composed in these contexts. So this is a very general thesis, and I would like to illustrate the validity of this thesis. We are going to discuss about its wider validity, but I would like to illustrate the validity of this thesis by another example that I'm going to take in ancient China. And that example is going to be that of the meaning of chapters in a given mathematical cultures, or in a set of mathematical cultures, in the context of which the Chinese book, The 9 Chapters on Mathematical Procedures, this is the title on the first line of this slide, was compiled, or in the mathematical cultures in which this book was recognized as a key reference book. So, a few words about this book. It was perceived as a classic soon after its compilation, and in correlation with the fact that it was perceived as a classic, commentaries were composed on it. And I will need to use today the commentary that was written down, completed by Liu Hui in 263, and the sub-commentary completed in 656, so sub-commentary meaning a commentary on the 9 chapters. This is how I'm going to abbreviate the title in what follows, and on Liouville's commentary by Lichtenstein and other people. So the 9 chapters is composed merely of problems, mathematical problems, and algorithms solved. As the title makes clear right away, it has chapters. And these are the chapters for which I'm going to suggest that they have a mathematical meaning. So the idea is that chapters, in this case, are not mere physical division of a book for the sake of ease, but the idea is that the chapters have meaning that adheres to a given way of doing mathematics. Beware that I have not said that every practitioner in doing mathematics in ancient China was engaged in the kind of practice that I'm going to describe, but I would like to put myself within the context of the cultures in China, the mathematical cultures that value this book, and I would like to discuss what people operating within this context read in chapters. And naturally, what I have in mind is to make the point that reading the meaning of the chapters is essential to account for the mathematics that is presented in the book. So let us start by reading a few words of the preface that Liouville composed for his commentary on the 9 chapters. He writes, "It is only when the Duke of Zhou established rights, we are here, this is here a reference to 11th century before the Common Era of China. So it is only, Liouville writes, when the Duke of Zhou established rights that we know that," and here there is something that I temporarily translate as 9 parts of mathematics, but as you see, I have put lots of red question marks because I'm going to revise very soon this translation. So it is only when the Duke of Zhou established the rights that we know that the 9 parts of mathematics, the 9, I'm going to call this thing shu. And there are other shu in the context of mathematics in ancient China, but today, if I say shu, I'm referring to these things that existed at the time of the Duke of Zhou, according to Liouville. So we know that these 9 shu existed. The development of these 9 shu, this is precisely what the 9 chapters is. And then he's going to tell a story of the book being lost because of book burning that occurred with the unification of the Chinese Empire and how the book was recovered, but I'm going to skip this. What is important for me is what is this 9 shu, the development of which led to the 9 chapters. Note that for Liouville, that means that the 9 shu and the 9 chapters existed before China was unified, and it existed in higher antiquity. And note that there are 9 things that we need to interpret an organization of mathematical knowledge, and they are connected in this statement with chapters that are book parts. So my questions are, what does shu mean here? What does development mean, which connects shu and chapters? And I'm going to focus on chapter as a key to the understanding of these notions. Second remark, it's interesting that recently many manuscripts were found most of the time in tombs, manuscripts from the last centuries before the Common Era, so that means manuscripts from the beginning of the Chinese Empire, and that none of these manuscripts that we can read so far has chapters. So the 9 chapters is distinguished by the fact that it has chapters. And remember that the title emphasizes the fact that the book has chapters. So how to interpret this difference in book parts, this difference between the manuscripts we have and this book that was conceived as a classic. In the first part, I would like to concentrate on the titles of the chapter, and I would like to show you what we can recover a title meant. In a second part, I would like to establish the fact that the reference to chapters in the title of the book, the reference to chapters, does correspond to an organization of the book in parts, because you know that ancient books were handed down, and one of the things that was mostly changed was precisely book parts. So we need to establish that book parts, as we see them, as well as titles, are things of the past and not things of later editors. And in the third part, I will turn to a hypothesis about the meaning of a chapter, or to the question of why there are chapters in the 9 chapters. So let me begin by mentioning the first occurrence of the 9 shu in relation to mathematics. The first occurrence of this expression 9 shu is to be found in a book called The Rights of Zhou Dynasty. So we have, it is only when the Duke of Zhou established the right that we know that there were 9 shu. In fact, in the book entitled The Right of the Zhou Dynasty, that is supposed to explain the organization of a governmental institution at the time of the Zhou, we have the occurrence, among the things that the children of high classes must learn, we have the occurrence of these 9 shu. And a commentator of the 1st century of the Common Era, quoted by a later commentator, I'm going to use his name, Zhang Xuan, regularly, so please remember the name Zhang Xuan. The commentator expands what these 9 shu mean and gives the following list: rectangular field, unhorsed grain, parts weighed according to ranks, and so on. And let me emphasize measures in squares, excess and deficit, poniards. Impossible so far to interpret this expression. We simply know that clearly it related to something related to the right angle triangle. And the commentator Zhang Xuan, quoting somebody from the 1st century of the Common Era, adds, in modern times there are reiterated difference, something which we do not at all understand, and third, new thing which appeared in his view in modern times, base and height. So why is it important to mention this commentary by Zhang Xuan about what the 9 shu are? It is because if you look at the titles of the chapter, of the 9 chapter, which I put on the left-hand side, and I put in gray on the right-hand side where I just read, you notice that there is a very close relationship. Rectangular field, unhorsed grain, part weighed according to the rank, blah blah blah. You notice that there was 2 chapters were swapped. You notice that this Honyar was replaced by base and height. And these are basically the differences between this list of 9 shu and the titles of the chapter of the 9 chapter. Yes?
Which was earlier?
This list is the list of the titles of the 9 chapter. We believe the book was completed in the 1st century of the Common Era. And this list first lists a list of things that are supposed to be early shu and gives us in modern times being 1st century. You will see that I have elements that are going to reply to this question. So we need to have the clarification of the similarity that I just brought to light, similarity between these 9 shu and the title of the 9 chapters. We need to clarify what that similarity means, and this clarification will come from answering the question which is my first question: what does the title of the chapter mean? So here you have the first page of chapter 3, and I translated completely the first page, or more or less completely the first page, on the right-hand side, and I'm going to show you how things correspond in the Chinese page. So here you have the name of the 9 chapters. I don't comment on the slight change of the name, we are not here for that. Book 3. You have the name of the commentator Liu Hui, the name of the commentator Li Chunfang, and in fact, we are in an edition of the beginning of 13th century, and in this edition, all commentaries were brought together with the text of the classic, and the 3 layers of text were handed down together. So we have here, upper in the margin, the name of the chapter, the title of the chapter. Here we have parts weighed in function of the degree. A commentary by Liu Hui explaining what is dealt with, what this chapter allows you to deal with. And then you have, and it's very clear that these are the same 2 characters. I think you need not know Chinese to notice that these are the 2 same characters. This is the name of the operation that the first procedure is going to execute. So you have the name of the operation alone in a column. This is a commentary by Liu Hui giving an alternative name for this operation. And in the next column you have a procedure, and you see in larger characters you have the text of the classic. In smaller characters and in 2 columns, you have the text of Liu Hui's commentary, unless you have a mention indicating that it is Li Chunfang commentary, and it will be also written in 2 columns and in smaller characters. Note that not all the procedures have a name attached to them, but here we have a name attached to the procedure, and the name attached to the procedure is exactly the thing which was used to make the title of the chapter. This procedure, as is very clear, is given outside any problem. You begin the chapter by a general procedure. There is a question which is open: when do algorithms relate to a name for an operation they execute, and when not? I am not going to address this question here. What I would like to show you is how the names of these operations are used. We see here, I will put blue on it, commentators using the name of operations to comment on the procedure. Here we have a proof that this procedure is correct, And to prove that this procedure is correct, the commentator is going to use operations, procedures that had been introduced previously. So these names reoccur in the commentaries. Some of these names are names of procedures like this one that begin a chapter. Other names are names of procedure that are in the middle of a chapter. And this procedure in chapter 3, this procedure that begins the chapter is followed by a set of problems that have the following format. You have the beginning of a problem. Suppose we have blah blah blah, a question, the answer to this problem, and a procedure. And in the commentary on the procedure that solves this problem, again, commentators are going to use the names of some procedures, and from time to time they are going to use the name of the procedure I have just shown, namely the name of the procedure parts way according to the degree. What I would like to establish now is that the title of the chapter is the name of the first operation of the chapter and not an incipit. You know that it's a very common phenomenon that titles be given as the first characters of a part of text. So what I need to establish is that the title is not simply taking up the first two characters to make the title. So what I want to establish is that the name of the chapter is the name of the operation which is placed at the beginning of the chapter and not the first two characters of the chapter. So for this, I need to do a little bit of philology. I'm sorry, but I'm going to do it very quickly, but this is important for the argument to be rigorous. I show you here the first page, and I'm sorry it's made out of two copies for technical reasons that are absolutely boring, so I'm not going to explain them. So you have here page 1 of chapter 1, and if you want, page 2. You have rectangular field here, and immediately after the title of the chapter, rectangular field, the first problem, its answer, the second problem, and you see here that you have something that was damaged. You see here that the beginning of the answer was erased, and you have the white column which indicates that there used to be two characters here, and they no longer are here. I can prove, without entering into the reasoning, that these two characters were the same as these two characters. One way of proving it is to go to another line of documents thanks to which we know the 9 chapters. These documents rely on the 15th century encyclopedia. We are here in the end of 18th century encyclopedia that restores the 9 chapters on the basis of a 15th century encyclopedia. The 13th century document did not exist at that time, and here we have the first two characters that are the same as the title of the chapter, even though the layout has been changed. Layouts are things that change when documents are handed out. First chapter, I have told you, this is the 9th chapter, and again, with the same, we are in the same edition. We have the title of the chapter, base and height, 3 problems, and again, we have the 2 characters that are the name of the operation that is described at the beginning of the chapter, base and height. It's the name in Chinese for the Pythagorean procedure. We have here a commentary on this name, base and height. I will go back to this commentary in a moment. And than the procedure that solves this problem. So we can see on the basis of these two chapters that the title is the name of the operation that is put at the beginning of the chapter. I'm not going to bother you with the detail of this page. This is the opening page of chapter 8, which does not exist in the 13th century edition. It was not preserved, so I'll show you the 18th century edition. The title again is missing. I don't enter into the detail because we are not in theology. But what I want to show you here is that the second problem of the 9th chapter uses the name of the operation measures in square. And so we can prove by a philological argument that I'm not going to develop that again in this case we have the name of the chapter, which is the name of the first procedure, and that the name of this operation is used in the 9th chapter itself. Now, the first conclusion I want to draw is that the titles of the chapters are in fact the names attached to the first procedure in each chapter. In some cases we have the first procedure outside the context of any problem, so these are the first two characters that occur. In some cases we have problems and they are not the first two characters. So we can establish that we do not have an incipit, but we have the title of chapters that do takes up the name of the first operation. So the next question is, why are the names systematically the same? What is conveyed by this organization of the text? What is the meaning of this dispositif? And it will be essential to understand what I am after, namely, what is the relationship between the 9 shu, we have not yet found what this shu means, and the 9 chapters, and how can I interpret the development that leads from one to the other. I'm going, in what follows, to do a second boring thing before I reach the crux of the matter. The second boring thing is to establish the fact that the chapters are not the fact of later editors. I need to establish the fact that the chapters existed in the ancient book. I've quoted here, and I put it in red for you to look at it immediately, segments of the 3rd century, commentary, segments that are referring to chapters, segments that are referring to parts of the text by indicating the chapters. In this chapter, blah, blah, blah. In this chapter, blah, blah, blah. I don't want to enter into the detail. The only example that I'm going to emphasize 2 examples. One is the comments that opens the 18th problems of chapter 8, which, referring to 2 procedures and 2 chapters, read the procedure by reading the essential feature, the essential achievement of the procedure. So we are not referring only to the operation, but to what is the core meaning of this operation, that is opening the chapter. I won't say more about this example, but the idea that every time we read, we look for a core meaning. The second example from the commentary on which I'm going to insist, because I'm going to come back regularly to this comment, it's a comment about the procedure that opens the chapter 2, not quite in fact, because before this procedure we have a table, precisely the table husked and unhusked grains, which gives its title to the chapter. And this first procedure, which the name of which I translate by suppose, is followed by the following commentary. This is, the commentator says, a universal procedure. All 9 shu that give their names to the chapters, and here the term that is used to designate a chapter is no longer the term that is used in the title of the 9th chapter, but it is rather a physical entity chapter. So all these things can be widely extended with the help of this procedure by means of something. We are not interested in the details, but we notice that we have here the idea that the 9 shu can be extended widely, and that there is a need to extend them. So there is here appearing in this commentary the idea that we have something that is extending, and we start seeing the theme of the development that is connecting these 9 shu and the 9 chapters. And now that I have established that all the chapters have for their name, for their titles, the name of the first operation, except chapter 2, to be brief, now that I have established that the chapters existed in the past, I'm going to develop my idea, and I'm going to provide evidence for the idea that chapters have a mathematical meaning. So, the question now you understand is, what does it mean to put a procedure at the beginning of a chapter? Since we have chapters whose titles are systematically the names of the first procedures, and in fact, if you remember, that means that these first procedures have names that are very comparable to the 9 shu, since the 9 shu and the 9 chapters had similarities, okay? So now we need to focus on these first procedures, and we need to understand what it means to put something at the beginning of a chapter. And here we are lucky enough that for chapter 9, right after the name of the procedure, base and height, we have first a commentary which explains the technical terms base, height, and hypotenuse for a right-angled triangle. And after the explanation about the technical terms, we have the following comment. The operation base and height, which corresponds for us to what we would call Pythagorean theorem. In fact, it's a procedure, that's why I translate as Pythagorean procedures, is about to be extended to all the situations, to all the algorithms. This is why the procedure is set out first so as to make their origin appear. And now you understand that this is a key statement because this statement is making clear the reason why this procedure was put first. This procedure was put first because it's going to be extended. And what is the connection between the procedures to which it is going to be extended and this procedure? This procedure is the origin of the other procedures. So all these terms, origin, extend, development, all these terms are related to each other. And for all these terms, you can find other occurrences again explaining why something is put at the beginning of a book in another book, the Moment of the Jaw, which is a book of mathematical astronomy, let us say. The commentator also explains in exactly the same terms why the procedure is put first. We can find other connections between the origin of something and the possibility of extending. So we have here evidence allowing us to establish that what the commentator believes is that the procedure which is put at the beginning of the chapter is a fundamental procedure which is the origin of the procedures that are going to follow in the same chapter. Let me give you an example of such an extension. I will give you the example of the first chapter entitled Rectangular Field. It can be proved on the basis of evidence that the term field at some point before the 3rd century took up the meaning figure. I cannot tell you whether in the 1st century it already has the meaning figure or not, but I'm just sketching this. In this chapter we have two components. We have fractions and the arithmetic of fractions, and we have arithmetic. And it can be shown that fractions were associated to a rectangle. A rectangle having as its width the numerator, something that corresponding to the numerator, and as its length, something corresponding to the denominator. And that all the arithmetic of fractions is thought of in terms of elongating rectangles or shortening rectangles, but keeping the same area. Whereas with respect to areas, in fact, the key way of reasoning with respect to area is transformation into the area of a rectangle. So one can make a case of how both the two components of chapter 1 are united behind the procedure rectangular field. Moreover, we have terms that we can pick up in the commentaries that reflect this interest for the extension of the procedure. We have the term universal procedure, which occurs twice, and twice to qualify procedures that are placed at the beginning of chapters. And we have this term extend that we met with at the beginning, in the commentary of beginning of chapter 9, but which we also saw occurring in chapter 2 and in fact also in Yogui's prefix. So as a consequence of this, I believe that we can interpret these 9 shu as referring to 9 fundamental procedures that are the origin of the chapters that they open, and that they somehow give their name to the part of mathematics that is going to be developed from that fundamental procedure. And so, in this context, the interpretation of the chapters would be that a chapter represents the extension of the opening procedure that gives the chapter their name, the extension of this opening procedure to the treatment of other topics. Now the question now can be, why is the fact that the opening procedure is essential, the fact that the opening procedure is the source of all the other procedures, the opening procedure will extend to cover the other procedure, why is this fact made clear in chapter 9. Well, we can provide a hypothesis for this if we remember the list of 9 shoes that John Schwan was quoting in his commentary of the book The Rise of the Zhou Dynasty. You remember that, and I put here again John Schwan's list of 9 fundamental procedures. You remember that this list comes from Zhang Zhong in the 1st century, and John Schwan quotes that we have 9 fundamental procedures, but in modern times there are 3, apparently 3, we don't understand the second one, I remind you, other things. And what happens in the book, the 9 chapters we see, is that Pangyang has been replaced by base and height. And so one may very well read the fact that the commentator explains why base and height is put here, because it is the source for knowledge about the right angle triangle. So somehow one can read the commentary as commenting the fact that it is no longer Pangyang, but it is Gogu which is put first, because it is Gogu that is the source of the knowledge that follows in chapter 9, and that is going to be knowledge about the right angle triangle. This is, in my view, how one can interpret what this development of the 9 fundamental procedures to make the 9 chapters that we read in Yuhui's preface at the beginning. You remember there were the 9 fundamental procedures at the time of the Duke of Zhou, and it was their development that led to the 9 chapters. So, to high antiquity, it is attributed to have the knowledge of the most fundamental, and the 9 chapters are the 9 parts of mathematics that derive from these fundamental procedures. What is very interesting is that in another book that Li Chunfang wrote, I don't comment about the nature of this other book because this is not interesting for us, we have another statement that is again using this concept of development, but this time it is to state the fact that these 9, and there is only 9 in the text, so we can interpret it as 9 fundamental procedures, or we can interpret it as 9 chapters. So these 9 all flow from, develop from a concept, which is the concept of Lu, and then Li Chunfang makes comments to capture the key, the core elements of these 9 fundamental procedures or 9 chapters, thereby concluding, hence, the methods of the mathematical procedures are exhausted by this. In both cases, I'm not going to develop this point, but these statements about developments are made clear by commentaries that analyze why procedures are correct and that bring to light either the first procedure of the chapter or core elements of the first procedure of the chapter underlying a given procedure. In this context, it is interesting to see that we have an echo between the comments I was discussing after chapter 2, after the first procedure of chapter 2, and this description by Li Chunfang of the organization of mathematical knowledge. What is the interest of this? you see that in Lichtenstein's latest statement we have lu as the origin from which the 9 fundamental procedures derive, and here you have an extension by means of lu of these 9 fundamental procedures. So you have Akin concerns, both in terms of extension. So to wrap up, we see that the classic embodies an understanding of which 9 procedures are the most fundamental. We have a continuity with the list junction quoted, but we also have differences. So this seems to indicate that this was a program embraced by several practitioners to identify which 9 procedures were the 9 most fundamental procedures. And this is why it's interesting to have variation in these lists, variation that seem to indicate that people disagreed and reshaped these lists of 9 fundamental procedures. I will not enter into detail, but we can establish that the 2 commentators betray 2 different conceptions of what the 9 parts of mathematics, the 9 main procedures are, and this has consequences. So let me conclude, and I would like to go back to the fact that I'm trying to capture features of a given mathematical culture, and I'm going to capture features that relate to ways of structuring text and meaning given to the way of structuring text. So, the 9 main procedures give rise to 9 parts of mathematics that are the 9 chapters. These 9 shu I established are the 9 most fundamental procedures from which all mathematical knowledge derives. And we have seen that we have a continuity with research to which Zhongshuan bears witness, and continuity with research carried on by Liu by Lichtenstein. These 9 fundamental procedures, and there I go back to the question of the chapters, these 9 fundamental procedures would be placed at the beginning of a chapter, and the chapter having the name corresponding to this procedure would embody the development of this fundamental procedure, which would be the source of this chapter in a sense that can be made clear. So, in my view, this is how the commentators seem to read the 9 chapters, and this is how I understand now this statement on which I pondered. Here I translated shu as part of mathematics. It would be perhaps better to do all 9 fundamental procedures that give their names to the chapters. This is the term shu, can be widely extended, and so on. So you see that we have this relationship between the 9 fundamental procedures, the development, and the 9 chapters. So each chapter, as a segment of text, has meaning in that it embodies a fundamental procedure and the development deriving from it. So, in this sense, the 9 chapters embody an organization of mathematical knowledge that is mathematically meaningful. And you see that at the core of this understanding of mathematical knowledge, one way of understanding the value of generality plays a key part, because it is the most general fundamental procedure which is placed at the beginning. I hope that on the basis of this question I raised, we can go thinking about the mathematical documents that we read. We can go back to think about the parts they have, the variety of parts in different kinds of texts, and the meaning that these various parts can have. Thank you very much.
Well, thank you, Karine. I have to say no one has seized the opportunity with emphasis biology technology. So we have 5 minutes for questions. Karine, if you're happy to identify people for desire to do that.
You mean that I should identify people?
Yeah, why not?
In case I know them, but I don't know everybody in this room.
Well, the people could give their names.
Okay.
We have a question at the back.
I saw, okay.
Yes, and my name is Sasha Borak. My question is totally textological, although I do not understand a single word in Chinese. Some of the slides which you showed, apparently photographs of manuscripts.
Printed editions.
Printed editions. They involve frequently some kind of something which looks like imprint of a seal.
Yes.
Is this indeed a seal? Is it actually some kind of library seal, or it is related? Yes, like that, for example.
So in fact, this edition is an edition that was it's part of a collection of precious books. This is a sub-editorial project from a huge editorial project. It was an encyclopedia that was supposed to republish the gist of writings in ancient China, and these seals, as well as these seals, are the seals of either the private persons or the institutions that possessed that document.
Okay. Well, thank you.
Jeremy?
Could you put back up one of the lists of the 9 titles of the 9 treaties?
This one?
Yes. I'm struck by the seeming difference between the generality which might lie, one might say, in the mathematics,
Yes.
which is hinted at by rectangular field, diminishing width, excess and deficit, measures in square. These seem rather mathematical, and I'm mathematically ignorant of unhusked and husked grains. And one of others of these. So I was wondering, discussing works, for example, if you see how you see these titles working. They play the structural role you described. And you said right at the start of your talk that sometimes these are removed from a problem context, something like that, and sometimes not. So is there an interesting story about these seemingly different kinds of chapter title, or is this an artifact of your English translation for me, as it were?
It is not an artifact of the translation. In case there is anyone in this room who can read Chinese, you can see it's not an artifact. You speak to someone who wrote a paper entitled Generality over Abstraction. And we tend to read these things as having varying levels of abstraction, if I may reformulate what you just said. Now, in the 9 chapters, if we rely on how the commentators read the 9 chapters, they don't make any difference with respect to generality, whether something is written abstractly in our sense of the word abstract or not abstractly. So we need to distinguish generality and abstraction, and we need to ask the question, where is there abstraction, not in our eyes, but in the eyes of Chinese practitioners, and why is there abstraction there and not there? But first of all, about the title Measures in Square. I have translated measures in square. Well, square is not right. In fact, measures in square refers to what one may describe as the writing of a system of n linear equation with n unknown, with the square of coefficients in a matrix form and below the constant coefficients. So the term Chang measures, it's not very easy to determine whether it's abstract or not abstract, but this procedure precisely is described, so it's the Gauss pivot, the famous algorithm which is the Gauss pivot to solve the equation. This procedure is described in the context of a problem that is dealing with various kinds of mills. The commentator starts his commentary as follows. This is a universal procedure. And you may remember that the other occurrence of the term universal procedure is after the procedure I called support in English, and which is outside the framework of the problem. And the commentator goes on. If we express it in what I could translate as abstract terms, it would be difficult to understand. This is why one ties it to Millet to make it understand. And what happens is that one can show that the formulation of the problem yields a situation in the context of which one can interpret the steps of the algorithm. So the use of the problem, which is in our eyes a concrete problem, and is read as something general, we need to address what it's meant for a problem not to be abstract. But I suggest that we do not use our own terms to refer to these things. I could go on and comment that grades were certainly a key thing in the economy of the ancient Chinese government, and it was certainly a key thing in the definition of measuring units, and the equivalences between different kinds of grades was a key thing for tax payment and so on. And it is in this context that that a very abstract concept, which is a concept of number defined relatively to other concepts of numbers, is introduced. And in fact, it's not only introduced in this context, but it is used in this context and in relation to tax payment.
I think we have time for one quick one.
Am I right in assuming that the number 9 of the 9 chapters is not an accident?
You're absolutely right in assuming that 9 is not an accident.
Okay. If this is so, what does this mean for the possibility of developing this thing further within this practice? So if you're not allowed to change the number of the total number of chapters, but you want to add some new idea, even it's not so clear, this thing in modern times on the slide that we see right now, whether this would give, I mean, if you put all them together more than 9.
You know, in fact,
You know, right.
but in fact, since people have not, you know, people have read the list that you have on your right-hand side as a list of chapters. And so they have not commented upon this problem precisely that you are raising. In my view, these things are candidates to replace the final chapter by another one. And now to go
So
back,
you have to replace.
this is my interpretation in relation to my interpretation of this text and its meaning. Because since the two things have the same list, it's very difficult to distinguish them. But I do believe that you must distinguish them, and that you can distinguish them, and that this allows you to capture the mathematical meaning of a chapter. So a chapter is not something in which you get a thing, but it states something by the fact that you are putting at the beginning of a chapter something specific. So, where you ask, is there room for further development? I could not develop. Let me go back to something that I have not developed. I could not develop a comment on this thing. But you read here, as for what is called U, there are 9 flowing from it or developing it. Then we have a list of the chapters. They, all, and then you have a fundamental operation. Oh, sorry. And a second fundamental operation, and a third set of fundamental operation, and a fourth fundamental operation. So you have a work that goes on, which is attempting to identify more fundamental operations than these fundamental operations. So I guess that we have evidence that some work went on to identify more fundamental layer yet. So in this way you get a tradition with a project which is to identify the most fundamental operations. But again, most fundamental operation, we should not approach this expression in an anachronistic way. It's fundamental operation not like the 4 fundamental operations of arithmetic, but fundamental operations in another way that needs to be described.
Well, we should have some lunch now. We're going to start. But they throw us out at 5:30 without any argument, so we have to be pushed to time, otherwise the last week. So we'll thank Karine for having us.